Okay, Paul, we're back. What are you doing?
Well, I'm fixing a fan I should have left on the side of the street.
Uh-huh.
But I can never resist a challenge. Let me get rid of that. There we go.
This is one of those cheapies.
This is the cheapie. And you kind of hear a little noise when you plug it in, but the fan won't run and the little lights don't light.
And you replaced the capacitor over here already.
And it wasn't that. So I'm going to take the little control board out. I mean, I can always hotwire it for one speed. I don't need this remote control thing.
And so you just run when you plugged it in.
Yeah. It's a good warehouse fan.
Mm-hmm.
I kind of like the size, and I've got the base to it. And
lots of times they make things unnecessarily complicated.
Well, it has a little water damage, but who knows?
What, did someone throw it away or something?
Yeah, it's on the side of the street. I'm going to start having a pop quiz after I tell people things. Yeah.
We're on air right now.
On the side of the street.
I'm having to repeat what we talked about earlier.
Yeah. Well,
for our viewing audience, so they're left out.
Found on the side of the street. So, let me see. There's one side of the line. The motor's tied white common to one side of the line.
Of course, the troubleshooting you do for this is like almost anything else.
Yeah, other side of the line comes around here and goes through one of these three, probably triacs or FETs, I can't tell which. Anyway, that IC turns them on one at a time to make the fan run. And the question is, why doesn't it run?
Now the question is, how do you know what all that does?
Well, if you did fan motors before, they all got complicated.
I just heard it beep.
Okay, it beeps.
Now if you get it running, the blades, are they able to move?
Well, the lights aren't coming on. It would beep, and the motor would try to run for a split second and stop, which is why I thought it was the capacitor. But none of this logic stuff is working. So I'm going to cheat and go around the logic stuff.
The odds of getting a replacement board for this is zero.
Zero. Absolutely zero.
And most people...
But some things don't change. The motor still has common and 3 run speeds.
Right.
With a capacitor on the motor to start the motor. And if the motor goes and doesn't spin, the capacitor is a likely suspect. Mm-hmm. This one, the fan turns freely, jump at the capacitor, motor didn't start, it's just not being powered by this little circuit board. So I'm going to move a wire from...
See, one thing about doing this, you're bypassing the circuit board.
I'm getting around this stupid circuit board.
And that's probably the number one failure thing in this.
Well, the number one failure thing on this is they run out of oil, so they get... The bushings get dry, they stove up, they sit there and they go, they get hot, and they blow the thermal in the motor where the whole thing is dead. Or that capacitor fails and they either run very slowly or they don't try to start at all.
Now the thing about this, what you're doing is something very environmentally important, because what you're doing is you're rescuing a fan that would go in the dumpster.
This has life in it.
Okay, that turned.
Of course it did.
Okay, so...
Motor's good, capacitor's good, stupid circuit board is bad.
Right, and but at least you made a usable fan out of trash.
And this was on the side of the street. Water could have gotten in it and killed it, or it could have just died.
Now, did you oil the motor?
A little WD-40 freed it up, yes. And it's obviously had a long life. It's full of dirt. But I hated to throw it in the dumpster when it was a good-sized fan with a nice pedestal and potentially had some life left in it.
Yeah, and see, this is where we talk about the environment, because this kind of fan is environmentally wasteful. Yeah. Because back in the old days, they'd make a fan, it'd last 30 years.
Oh, easily.
This fan maybe lasts 2 years.
Yeah, maybe 5.
Maybe 5.
But you see these on the side of the street all the time. The grease is dried up. They put wax in the oil, I swear. They get gummy, they slow down, they stall, they get hot. They blow the safety fuse in there so they don't catch fire. The fuse in the motor is replaceable, but it's tedious. You got to dig in there, find out where it is. Some of the motors, if you know the motors well, the safety fuse is between one side of the line, like the white, and one side of this capacitor, you can tack it in here. But it's actually wound in, either clamped to the windings or wound into the windings so that if they get hot, it shuts down. It's a fuse that once it gets too hot, it opens, it does not reset.
So there's a lot of safety issues with this fan you need to be aware of.
That's why they don't catch fire. But they know if they put that fuse just at the right temperature, even if the motor doesn't lock up, eventually it's going to blow that fuse, it'll be dead, they'll throw it away. I've opened these up and repaired them. It's not really worth the time it takes, but I can do it.
So all this metal, not that much of it nowadays, and all this plastic.
Plastic's what killed. The metal will eventually be mineable. The plastic will be there forever, and it's useless.
And so this is
yeah.
You know.
This one I can move that wire, put it back together, and plug it in, and I've got a fan.
You know, a fan from the 1940s most likely even works today. Are easily repairable.
Well,
this is
after 70 years, the bushings do wear out, but you clean them, you oil them, and chances are they're going to run.
Yeah, and so this, on the other hand, you'll have to have like, 35 of these if you're lucky. And so you just make a pile of 35 of these fans compared to one of those fans that works.
Yeah, over the period of 50 years.
Yeah, it's like the washing machines. The washing machine may make it 5 years now.
If you're lucky.
If you're lucky. I have a Maytag that's going on its like 45th year.
Yeah,
works perfectly. Minor repairs. And so, I'm talking about 9 washing machines I didn't throw in the dumpster.
And that's a lot of plastic these days.
A lot of metal and everything. And so, making things that don't break down because you want to make more money off of them.
That's just wrong.
Is very environmentally friendly. So you're deciding to change the speed again?
Yeah, I'm going to hardwire it for medium for the moment. That's probably as fast as I'd ever run it anyway.
And of course, you had to be very safe with this because this is 110 volts, so you don't want to have it plugged in.
It's unplugged. I double checked that because once in a while you forget.
And you know this by looking at the white wire coming in.
Well, you know from past experience with motors like this that you've got a common and 3 hots.
Right.
And it's 3 different speeds. And the common wire.
So you'll find the common going to the white wire coming in.
So the side of the line that goes to the white one, that's common. It says common right there. There's the other side of the line, which is the hot. It's around, goes to these 3, I'm assuming they're triacs, that are turned on one at a time by this IC. And obviously they're not being turned on because it doesn't turn on. But you wire the motor straight to one side of the line, it's going to run.
Yeah, and you won't have to worry about that board at all.
And I
you can never
disconnected
get anyway.
the other 2 windings. In case one of these turned on, you don't want 2 windings turned on at once. I'll tape these off, stuff it back in there, and next summer I will have a garage fan.
Right. But remember, you have to be cautious working with this voltage.
Oh, yeah. You need to know what you're doing. Make sure you unplugged it.
But this is you just saved a whole bunch of stuff from going in the trash.
Yeah,
is that bad there?
I've got a cord there I need to fix.
So you'll replace that cord because it's been bent so many times. The insulation's where it gets short right in the middle.
I'll take care of that. It'll have another
You got to
season.
watch that with a lot of pieces of equipment where the cord.
Yeah, this plastic gets brittle. It gets stiff and brittle pretty quick.
Yeah, and I think that isn't a lot of motion all the time.
Being an oscillating fan, well, the oscillating link is right here. This one's just coming off the back of the handle, but who knows how this thing got to drag around.
But lots of the insulation they put on the new cords tends to break at a point like that.
It's vinyl and it hardens.
Yeah.
This one's got the oscillator thing broken off, but I can take or leave that. Well, that's not a big deal. I can glue that thing down, just have me a fan. With global warming, it's getting hotter every year. We're all going to need fans.
And maybe if we didn't dump all these fans in the trash, we wouldn't have so much global warming. This stuff is made out of oil.
Yep.
And so you have to, you multiply all this plastic that you put in all these fans, and look at all the oil you have to get. I mean, it's not like a car, but still, this is wasteful.
Everything.
Yeah.
Yeah, this takes like half a barrel of oil to make this amount of plastic. It's ridiculous. But they get a lot of byproducts in the same time. But yeah, this is saving one from the dumpster one last time. Eventually, it will end up in the dumpster, but not yet.
But it keeps you or someone else from having to buy a fan.
Yeah, it could come in handy.
Yeah.
I do it because I can.
If you repair these, you force the people that make them to actually make them better, because then they might sell them.
They'll never change.
Yeah.
They'll never change. But I do it because I can do it, and that's all.
Yeah.
That's it.
But the thing is, planned obsolescence is environmentally devastating.
Not good. Everything's cheap. Cheap, 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 cheap.
Yeah.
So that's why my little projects, just because I can do it.